Welcome to Problem 6 on the 2021 AP Calc AB exam. Links to the problem and the scoring guide are in the description. A medication is administered to a patient. The amount in milligrams of the medication in the patient at time t hours is modeled by a function y equals a of t that satisfies the differential equation dy over dt. At time t equals 0 hours, there are 0 milligrams of the medication in the patient. A portion of the slope field for this differential equation, dy over dt, is given below. Sketch the solution curve through the point 0, 0. Now this problem wants us to know if we can draw curves using a slope field. So all we need to do is draw the curve so that the line next to it is parallel and it goes through the point 0, 0. There's no need to do any computations here. Using correct units, interpret the statement, the limit as t approaches infinity of a of t equals 12 in the context of this problem. Well, if we take a look up here, it tells us that a of t, which is the curve that we're dealing with, is the medication in the patient in milligrams based on the time. So this limit states that as t approaches infinity, or as t gets bigger and bigger, the amount of medication in the patient will approach 12 milligrams. Make sure you tell the AP grader specifically what these numbers refer to and the units, just like I did here. Use separation of variables to find y equals a of t, the particular solution to the differential equation dy over dt, with initial condition a of 0 equals 0. So another way of saying this is to find a curve that follows the slope field and goes through 0, 0. First, we'll put our y values on one side and our t values on the other. This way we're left with something that we can then anti-differentiate. We want to then find an equation in terms of t, so I'm going to put our plus c on the side with our t variables. From here, we plug in our initial condition, which is 0, 0, then we can solve for y. A different procedure is used to administer the medication to a second patient. The amount in milligrams of the medication in the patient at time t hours is modeled by a function y equals b of t that satisfies the differential equation dy over dt equals 3 minus y over t plus 2. At time t equals 1 hour, there are 2.5 milligrams of the medication in the second patient. Is the rate of change of the amount of medication in the second patient increasing or decreasing at time t equals 1? Give a reason for your answer. To find whether the slope is increasing or decreasing, we need to find the rate at which the slope changes. In other words, we need to find its concavity. We can do this with the second derivative. So what we'll do is take the derivative of dy over dt, which will give us our second derivative. I'm going to use the quotient rule for this, and I've sped this process up, but feel free to pause and take a look at the work if it's too fast. Now that we have our second derivative, we need to solve for our unknowns. We know that we're dealing with the case where the time is 1 hour, and there are 2.5 milligrams of medication in the patient. So we know t equals 1 and y equals 2.5. To find dy over dt, we can plug these into the dy over dt equation that we're given, and from that we know the slope at this point will be 6.5 over 3, or something equivalent to it. So now all there is to do is plug in our values, and we get that our second derivative is negative 4 over 9. In order to tell whether the slope is increasing or decreasing, we need to focus on the sign of the second derivative, and we see that our value is negative, so we know that the rate of change is decreasing. Try to be specific in your final answer like I've done here. That's all. I hope this helped.